Hi, in this video we are going to discuss about one of the DP based case study on formation of fibrous, nanofibrous, alpha-spun polyethylene scaffold containing alpha for bone tissue engineering. The abstract of the study was in this research I have used the electrospinning technique for the fabricating the scaffold. Electrospinning is a common technique used for the fabrication of nanofibers from the polymer solution. In this study, we have concluded that the addition of almond oil improved the tissue chemical properties of the scaffold, which can be suitable for the bone tissue growth. First, we will discuss about what is bone tissue engineering. Commonly, the various defects occurs in the bone are tumor ablation, bone science, osteolysis, and neurosurgical effects. For treating these defects, we are using the commercial elements such as allograft, autograft. However, they possess some disadvantages like scarcity of donor, infections, and immune rejection. So, there is a need for one alternative approach, which is called bone tissue engineering. Bone tissue engineering utilizes the scaffold containing the tissue for the remodeling damaged tissue. First, electrospinning. As we stated previously, electrospinning is a common technique for fabricating nanofibers. In this electrospinning, the polymer was converted into the polymer solution. Then it was loaded in the syringe pump. On applying voltage, the polymer solution was converted into nanofibers and finally deposited on the collected drum. Next, in this research, I have used polyurethane. Why I have used polyurethane means it was very cheap. Further, it was easily processable. Further, many studies have reported the formation of foams, membranes, films for wooding application. So, I have used polyurethane for my research. Next, I have used almond oil. Why I have used almond oil means almond oil contains many fatty acids, carbohydrates, proteins, which may be considered as biomolecules. So, I have used almond oil for my research. Further, it also contains the vitamins and proteins in the oil. Further, many research has been reported the anti-inflammatory, antioxidant study of the research. So I used the almond oil for my research. Next, first preparation of solutions. For electrospinning solution, we have to convert the polymer into solutions. For weight fraction, I have used the 9 weight fraction for polyurethane. For almond oil, I have used the same concentration, 9 weight fraction. For the PU almond oil, I have used the 8:1 ratio for the fabrication of composite solutions. Finally, the solution was transferred to the electrospinning technique, and finally, the scaffold was formed. Next, after fabricating, it was sent to various physicochemical characteristics such as scanning under microscopy, Fourier transform, infrared spectroscopy analysis, contact measurements, thermographic analysis, and atomic force microscopy. First, we will see about the cell investigation. Cell investigation defines the fiber morphology of the scaffolds. It was shown from the figure. The PU membrane showed a fiber diameter of 890 nm, while PU almond oil showed 629 nm respectively, which clearly indicates addition of almond oil reduced the fiber diameter to PU. It was clearly shown in the literature that the PU almond oil showed smaller fiber diameter which can be suitable for the osteoblast cell adhesion and proliferation. The corresponding image was shown, which was shown the first image was the PU and the second image was PU almond oil, which clearly indicates addition of PU showed smaller diameter compared to the PU. Next, FT analysis. FT analysis used to confirm whether the almond oil present in the PU. Further, FT analysis was also used to confirm the chemical composition of the scaffolds. For here, the PU contains chemical groups such as NH-CH-CO groups. For PU almond oil also the same groups were present, but one difference was it was found the intensity was increased compared to the PU, which clearly indicates the PU contains almond oil. Next, contact measurements. Contact measurements is an important parameter in the biomedical applications, which clearly predicts the metallurgy of the scaffolds. The PU showed a contact angle of 100 degree, while PU containing almond oil showed a contact angle of 107 degree respectively, which clearly indicates the hydrophobic nature of the scaffolds. It was clearly noted in the literature that the hydrophobic surface will be suitable for the osteoblast cell adhesion and proliferation. Next, thermostability. Thermostability was important parameter also in the biomedical application, which clearly indicates the thermal degradation behavior of these reference. In my study, the PU showed a thermal degradation of 270 degrees Celsius. However, PU containing aluminium showed a initial degradation temperature of 284 degrees Celsius, which clearly indicates the addition of aluminium input the thermal stability of the PU. The next surface roughness. Surface roughness is also important parameter in the biomedical applications. The first in my study, the addition of PU showed the rougher surface compared to the PU. PU showed the surface roughness 31 degree nm respectively. PU aluminium showed the rougher surface roughness 32 nm respectively, which clearly indicates the addition of aluminium input the surface of the PU. It was also clear in the literature that the input surface was favorable for the osteoblast cell adhesion production. Hence, in my study, PU aluminium showed a rougher surface which is suitable for the bone tissue growth. The corresponding AFM image was shown. The first image was the PU, while the second image was the PU aluminium, which clearly indicates PU was smoother, while PU aluminium was rougher compared to the PU, which clearly indicates the PU composite have the rougher surface compared to the PU. Okay, thank you.